Hello, this is the Cloud Native Hacker, and welcome to the channel where we discuss cloud native security and other related topics. Before we start, a quick disclaimer. This channel isn't affiliated with any employers past, present, or future. Its content is purely for educational purposes. Always ensure you have proper authorization for penetration testing or security assessments. The information provided here is not legal advice. Today, we will be taking a look at an attack targeting serverless functions in AWS, also known as AWS Lambda. We will be targeting a deliberately vulnerable Lambda function along with some other cloud resources. After we exploit the Lambda function, we will then use an open source exploitation tool called Pacu from Rhino Security Labs. We will use Pacu for our post-exploitation fun. Join us as we take a look at how you can still get owned even without a server. Before we jump into the details, let's take a look at Lambda functions and their potential vulnerabilities. Lambda functions are part of AWS's serverless offerings, which is great because it means that you don't have a server to manage. There's a lot of advantages to this type of architecture, such as cost, flexibility, elasticity, and reduced operational overhead. But just because Amazon handles the servers doesn't mean that a Lambda function is inherently secure. So what exactly is the attack surface for a Lambda function? Well, there are a few components. First off, we can't escape the classic issues that are associated with any application, regardless of what platform they're run on. This includes things like CSRF, SSRF, injection vulnerabilities, you name it. But one of the more interesting attack surfaces is the fact that a Lambda function can actually act as a pivot inside of your network. Lambda functions can be connected to a VPC. If a Lambda function has access to your VPC and it gets exploited, then that means that there's a potential way into your network through that Lambda function. Lastly, this issue is a bit more prevalent, especially in the cloud environment, but we're going to take a look at IAM security. Each Lambda function has an IAM role attached. If that role has excessive permissions, then that means that once you exploit that Lambda function, you potentially have access to act as that Lambda function. That means if that Lambda function is able to read all your S3, all the data in S3, then now the attacker can read all that data in S3. So it's really important to make sure that that IAM role is secure. Today we're going to be focusing on two of these areas. We're going to be taking a look at the application security. We're going to use that vulnerable Lambda function. And then we're going to take a look at IAM security. What role does that Lambda function have and how can we abuse that? Now let's get into the setup. So let's dive into what our tech setup looks like for today. Today, I'll be on a Windows 10 box with VirtualBox installed on it. We'll be targeting an AWS account with a modified version of a CloudFormation template from a Trend Micro immersion day for AWS. I'll include a GitHub link in the description, and then we're going to be leveraging a Kali Linux virtual machine with Pacu and the AWS CLI installed. Okay, so I am in my AWS account right now, so let's go ahead and go over to CloudFormation, and we're going to create a new CloudFormation stack. So this, if you're not familiar, is an infrastructure as code tool, and we're going to go ahead and upload. I'll include this link in the description, but we're going to be uploading the template from that repo. So let me go ahead and find that real quick. Okay, and let's just step through this. Give it some name that's useful, hopefully. Then we should just be able to click through here, knowledge, next, and then while that is in progress, let's go ahead and switch over and take a look at some of the resources that are created here. So this CloudFormation template will create a number of different resources. We've got a couple Lambda functions here. We've also got API gateway. We've got different IAM roles, as well as an S3 bucket to host the static assets. The reason why we're using a modified version is because there was just a ton of different resources that were created, so it wasn't necessary for our demo here. I didn't want to pay for those, to be quite honest, and it makes it a lot more complicated to get through. It's a good exercise if you're able to go back and take a look at the immersion day. I would recommend it. There's a few different exercises in there. Because of how I've limited it, we are only going to be taking a look at the command injection portion. Any of the other links will still be included, but they are broken links for now. And let's switch back over. As you can see, our CloudFormation stack created successfully. This is where you'll go, so that way you can find the URL for this testing. We'll go ahead and open that up. And as you can see, this is again from Trend Micro. The malicious file upload, illegal file access, those links are all broken, but the command injection is currently working. So we'll take a look at that coming up here soon. As you can see, this is a page where theoretically you would put a domain name in here and it'll perform a DNS lookup for you. So go ahead and type that in, click submit, and then we get the response here. The problem is that this input doesn't properly sanitize the user input, and we can actually go ahead and execute other operating system commands. As you can see, we get the response for the google.com DNS lookup, but we also get the user associated with this application. Now that we've shown that this function is vulnerable to command injection, we're going to go ahead and use the second command that they show here. And what this will do is print out the environment variables. And as you can kind of see here, it's a bit of a mess, but there's a session token, there's access keys, and there's an access key ID. So we can use this actually if we switch over to our Kali machine, and we can go ahead and use these credentials to go and configure our AWS CLI and configure Pacu for our post-exploitation fun. All right, now let's use these credentials to go ahead and set up Pacu. Go ahead and run Pacu. We'll just create this. This is the first session. Give it a simple name here. Great. Okay, and from here we are going to go ahead and set the keys. Okay, so we will call this Lambda, and we're going to go ahead and just copy the values that we got from above. So we're setting the access key. Let's find the access key here. Why am I not seeing it? Because I'm blind. Here we go. Go ahead and copy that. I use a lot of different operating systems and different things, so I'm never sure what copy and paste is at that given moment. We'll go ahead and set the secret access key and the session token as well. So right now we are setting the secret access key. You are welcome to go ahead and try these values by the time this video is up, but the environment will be completely gone. So, and if it's not and you're able to get in, then definitely let me know, because I don't want to be paying for that. Session token, okay. Go ahead and get that copied. Okay, so now we've got the keys. I'll go ahead and just show what the modules are, so we can kind of take a quick look at that. So you can see it's got a number of different categories. We've got some persistence, enumeration. We've also got some exploitation. Theoretically, these can be used unauthenticated against the account. It'll just try various roles and users. Data exfiltration, lateral movement, and then some evasion as well. We can definitely dive into this in the future if that's something that you would be interested in. Please leave a comment below. At least to me, I really like the idea of these evasions and kind of taking a look at what sort of logs its Pacu is leaving and what sort of logs it will try to tamper with as well. Okay, so now that we have the keys, let's go ahead and try to run this IAM privilege escalation module. Oops. Okay, so we're going to go ahead and try to rerun that scan with new permissions. Great, so the keys had already expired by the time that I got them configured here. Is there a specific policy you want to target? No, we will just run it and see what we get. Looks like the current user's confirmed permissions have not been enumerated yet, so no valid policy can be defined. Yeah, so we want it to enumerate the IAM permissions and see what sort of permissions are associated with this user. Okay. Wanted to come back and say I attempted to use all of the IAM enumeration, and including even this IAM brute force permissions. I didn't find this module to be especially accurate or useful in helping escalate privileges. So we are going to go ahead and just try poking around a bit on the CLI. So I'm going to go ahead and refresh some credentials here. So we're going to we're going to switch back to our box here, get some new creds. And then we are going to go ahead and export these variables so that way we can use them on the CLI. And I've already done some testing. I found a lot of permissions that I was unable to use, as well as one that I was able to use. So we'll kind of just walk through what I was able to accomplish here. Okay. So first thing we're going to do is we're going to try and get some additional information about these credentials. So we use this AWS STS get caller identity. So this checks against the keys that are currently configured, finds out the account, the ARN, and the user ID. So we'll be able to use this. So I found this when I was trying to enumerate some of the permissions with the role here. So this lists the AWS managed policies that are attached to this role. From here, I cheated a little bit by taking a look at the role itself, and I saw that we can actually attach roles using the role associated with the Lambda function. So we are going to go ahead and attach a role. So we're supplying it with IAM read only, so that way it can go ahead and do some more of that IAM enumeration, and we're supplying it to this role here. So let's go ahead and set our keys again here. let's go ahead and we're going to search IAM, and we're going to go ahead and see what sort of permissions we have. Cool. Incredibly useful here. Let's see what we can do. Okay, so now we've got different roles at least. These are all module based as well, so I'm just from my running into things, some of the modules seem to work better than others. So let's go ahead. We will, what are we enumerating here? We're going to enumerate our vulnerable Lambda role. We're able to do the privilege escalation. So I guess this will do more than just scanning. It will actually attach an admin policy. Okay, so let's switch back to our AWS console here. And let's take a look at the IAM roles here. So we can see this is this IAM read-only access. This is when we attach the policy using the CLI. And then this administrator access is what we were able to use when we ran the privilege escalation module in Pacu. Let's switch back over here, and I am going to search again for backdoor things. And let's go ahead and run one of these modules. Let's see, backdoor. Let's add some access keys. Okay. So it needs to run an additional module first, so we'll go ahead and run that. This is my user. We'll just go ahead and backdoor that. Why not? Okay. So now we've got keys here. Again, feel free to try them. If they work, let me know. I will be revoking those soon. But now that we've backdoored the system, right, we can go ahead and pivot and pretty much do whatever we want, because we've got the ability to attach policies using the Lambda function. We've got a backdoored user, so we can create users. We can add administrative policies to those users. Pretty much the world's our oyster at this point. We can search for data. We can do anything. So let's go ahead and set keys using our new backdoored user. We'll just name it that. And we'll give it our secret access key here. Okay. So now, as you can see, we're using the Dean permissions. So let's go ahead and search for modules here and just see enum permissions. Let's go ahead and check that out. Good. Another module that maybe isn't quite working like I would expect. Okay, this is odd. As far as I know, that user has full permissions. Maybe this is why. Let's clear that. Let's go ahead and rerun these and see if that gives us anything different. Okay, great. So it looks like that session token from our Lambda function was interfering. So I went ahead and cleared that, and now we are able to get the roles. Let's go ahead and take a look at our permissions. So okay, so we can get a look at all of that IAM information that Pacu has collected in its local database. See if I can oh, that's cool. Okay, so I guess that helps. So there is a command, who am I, which will just give you information about the current user. So as my user is an administrative user, you can see I've got privileges for everything. I wanted to take a quick moment just to talk about how this vulnerability came about and talk about some of the actually positive things during our work here. So if you take a look at this is a role associated with the Lambda function that we're targeting. So as you can see, it has the ability to list attached role policies, and it has the ability to attach role policies. Luckily, it's actually got a really constrained set of permissions otherwise. Unfortunately, that IAM attached role policy really gives you the freedom to do pretty much anything. So what that does is it allows you to attach the AWS managed policies to any role that you like. The positive for this is because the actions were so limited, enumerating what sort of functionality this role could do was actually somewhat difficult. I imagine if I were, targeting a company or something, I would have more time to go ahead and do that enumeration. But I think it would be incredibly noisy as well. So there should be plenty of opportunities to detect these sorts of things if a policy like this were locked down, or were this locked down. With that said, really consider whether or not a Lambda function needs to have these kinds of IAM permissions. IAM permissions are incredibly important in the cloud. Now that we've had our fun, I just wanted to quickly recap everything that we did today. We exploited a vulnerable Lambda function. We used that vulnerable Lambda function to gain access to the IAM role attached to that Lambda function. Then we elevated the permissions associated with the role, and we used that role to do some enumeration using Pacu. And then we used Pacu to establish a persistence mechanism by backdooring an existing user and adding a new set of access keys. Another thing before we end today's session, don't forget to go ahead and delete that stack so that way you're not running a vulnerable service, and make sure any of the roles that were altered or any of the users that you may have altered are also cleaned up, and you can also clean up any of the S3 resources that were created during this. Thank you for joining us today. If you found anything of value, please leave a like and subscribe. Set notifications on Instagram. I also have a Twitch at Cloud Native Hacker. I will be streaming someday. No immediate plans for that, but I do have future plans for some Twitch streams. Until next time, this is the Cloud Native Hacker signing off.